There's a very close relationship in C++ between arrays and pointers. And in this lesson, I'd like to demonstrate that relationship. So let's begin by creating a very small array. In fact, we'll only have 4 elements in that array so we can keep the accesses simpler. We'll call this array numbers, and we will initialize it to the numbers 5, 10, 15, and 20. You'll see why I chose those numbers in just a moment. So we know how to access the elements of the array using a loop, and let's just refresh our memory on that. ++i, and then cout numbers sub I, and we'll put a comma, well, let's put a space between the elements. Let's build and run that program. So we see 5, 10, 15, 20. We can create a pointer to the first element of the array like so. So we're going to say int pointer to numbers equals numbers sub 0. So to create a pointer to the first element of an array, you provide the first element of the array's address, putting the address of operator, the ampersand, right before the access to the first element of the array. So now if we write out that value, we won't bother with the address because we know we're going to get the address if we don't dereference the pointer. I just want to show you that we can get the value using the dereference pointer. So let's access that. So you see that the dereference pointer points to the first element 5. With a pointer to the first element of the array, we can then retrieve the second element of the array using what's called pointer arithmetic. First, I'm going to show you how not to do it. Because pointers point at addresses, and we know that arrays are contiguous addresses of memory, so you would think that adding 1 to the dereference pointer that points at the first element of the array would point at the second element, like so. Let's build and run that program and see what we get. But we don't, we get 6. I should have put a space there. Let me fix that. Let's build and run the program again. First, let me close that. There we go. And the reason for that is because of order of precedence. The dereference operator has a higher precedence than the addition operator. So instead of getting the next element of the array, we got the first element of the array plus 1, 6. So if we want to get the second element, we have to put the plus 1, the pointer plus 1, in parentheses like so. Now when we build and run this program, we get the next value. So it looks like we could write a loop like we did without pointers to access the elements of the array using pointers. So let's give that a try. So we're going to say for int I equals 0, I less than size, ++i, cout p numbers plus I, and then a space. And when we build and run this program, we should get the same access. 5, 10, 15, 20, 5, 10, 15, 20. Array access using pointers is a little bit faster than doing it using subscripts. It is a bit more confusing, and to the uninitiated it might not make a lot of sense, but for an experienced programmer, using pointer access rather than subscript access is a little bit faster. But before we leave this subject completely, there's one more thing we can do. It turns out that the name of an array is actually a pointer to the first value of the array. So rather than have to assign a pointer like this, where we created p numbers, we can use the array name numbers as a pointer into its own elements. Let me demonstrate how that works. First, let me comment out this other code so that we don't get confused. So, if that's true, we can use an array name as a pointer into the array. Then if we write star numbers, we should get the first element of the array. Let's try it and see what we get. And indeed, we do. So clearly we can write the access loop as we did above, that's commented out now, using the array name rather than having to assign a pointer to that array. So let's give that a shot. We'll set int I equals 0, I less than size, plus plus I, and then cout star numbers plus I, and put a space between, build and run the program, and there we get the 5, 10, 15, 20. So as I said at the beginning of this lesson, there's a very close relationship between pointers and arrays in C++, and it turns out it's closer than you even think, since an array name can be used as a pointer into the array itself. In the next lesson, we're going to look at a special operator you can use with pointers called the sizeOf operator.